didn't have to.
Yeah.
Okay. I didn't know if there was a place we got stuck or anything, but I think we just practice it up, and then if we have some extra time, I'll just work on homework Sunday. I'm down with that too. We have 2 different versions, bud. I finished making keys this weekend. So there's an A and a B, and then a makeup. And I think it should be A, B, and then makeup. And you're just saying right or wrong. If wrong, you know what to do. Slash through and write the right answer. Is that good? Okay. And I have a blue pen I brought over somewhere.
You brought it here and then you took it back.
Yeah. Oh, I took it back once. Thank you, Sam. Just going to Chipotle tonight. $3 dress up a little bit. No, no.
Yeah, you get $3 burrito.
Any burrito, bowl, salad, tacos, as long as you're dressed up.
And then they're
You get double meat or
the
broccoli.
donations go to like something.
Oh, they're doing donation? That's cool.
Yeah, like the profits they make, they're sending it to like something else.
You're right, I didn't do that. But I didn't do it.
It's I think $1 million will give away to something Chipotle agriculture.
This one, did you sub work perfectly or are you off by a constant? Oh, sorry. Hi, Joyce. Hi, Gerardo. Gerardo, hope you get feeling better if you're sick, bud. Joyce, I think you're here. I'll see you soon. We're just starting off with examples, pretty much just examples till the end, a couple things that we're going to peek at really quickly. But that's about it. So they were starting to choose their u's. You guys got x cubed plus 1? Du is equal to 3x squared dx. So it's off by off by a constant. I'm just going to pull the 1/3 over. So that way we can plug in for x squared dx, right? Maybe plug in, chug in for that one. What can I do with the additional 2? Yeah, just take it out. Just go ahead and keep the integral for right now. The x squared dx is going to become a 1/3 du. I like to sandwich everything, and then my u is just going to be, it's just u to the 4th, right? The bounds disappeared. It was on purpose. How do I keep going? What do I do with that 1/3?
Pull it out.
Yeah.
Is that the same thing as solving for dx and then substituting that? So
Oh, yeah, I forgot we started that last year. Sorry.
is that the same thing? That's 4 to the 5.
There we go. I forgot last year that I showed it a different way. The 2 can still be pulled out. We have the x squared, x cubed plus 1. We could just make our u. So the 4th, then we have, plug it in for dx. Our du over 3x squared. The nice thing is that x squared cancels out perfectly. This 3 can come out as a 2/3. That works, yeah. 4 du. Power rule backwards. Yeah. 1/5 u to the 5. I'm going to plug back in the x cubed plus 1. Why am I not putting a c, a plus c, and instead I'm putting a negative 1 to 4? Yeah. Good. There are bounds, and when I go to plugging in for FPC, f of b minus f of a, antiderivative of the top minus antiderivative of the bottom, the c's for each would cancel, so it doesn't really have much bearing. We have 2 over 15. 2/3 times 1/5. Then I can go ahead and plug in chug. I'm just pulling the constant out, so they're going to be similar. 4 cubed 64, 64 plus 1 is 65 to the 5th, minus negative 1 cubed is negative 1 plus 1 is 0, right? 0 to the 5th. And then 2 times 65 to the 5th, all over 15. I'm sure that kind of reduces sometimes. Because the 5 has to go into 65 to the 5th, but 18 and 125. We just box it and say we're done. That's done. Done. You get a decimal?
Yeah.
What did you guys get?
Yeah, I'm kidding.
1, 5, 4, 7, 0, 5, 4, 1, 6, 1, 5.
Ooh, that's a big number. Hold on, any more room. One more time. 1, 5, 4, 7.
0, 5, 4, 1, 6, 1, 7.
Was that even? 0.7?
Yeah.
That's a little big. Question: how did we solve the definite integral this time?
With, use the
X.
Yeah, u sub, got it back after solving the antiderivative, got it back in terms of x by plug it in,
So you want u down.
and then I plugged in my x's and then I had my final answer. But we can also do it with u bounds. The other way of doing it would be the exact same step that I said to the u sub, right? So exact same example, we can technically just write it down underneath if we want. What if we were to get u bounds? What if we were to change the variables and not change back? Then we would not only do our u sub that we just did of x cubed plus 1, and then du is equal to 3x squared dx, and then dx is equal to du over 3x squared. But we also would have done u of 4 and u of negative 1 using the u that we just established. And plugging in 4, of course, we would have gotten 65, and plugging in negative 1, we would have gotten 0, which is exactly what we just saw. So either way you do it, you still have the same work involved. But this way, I can easily change to u's and go from 0 to 65. Remember, whichever one's on the bottom is going to always be in the bottom position, even if it's a bigger number. And whatever's on top is always going to go in the top position, even if it's a smaller number.
And then you get 2/3 times the integral of
Good. By the time we do the u sub, right, of u to the 5th du. Nope, u equals u to the 4th.
u to, yeah, 2 to the 4th, but then you get 1/5.
There we go. So we have 2/15 of u to the 5th, which we would then evaluate from 0 to 65, which would then end up equaling 2 over 15 times 65 to the 5th minus 0. Shouldn't make any difference, right? It's based on personal preference to some extent, but as some of us have seen before, the AP guys love to force our hand sometimes and make us use u sub, even if we wouldn't otherwise. And they don't do it in the sense that they force us, like, on this following problem, use u substitution. Instead, they're just like, oh, hey, I'm not going to tell you the function at all, I'll just give you clues and you have to know how to use them. So knowing how to do u bounds is a helpful thing. And technically, isn't this a bit more like exact, a bit more precise? The bounds don't just disappear like the other one, because we can't write the bounds, like that doesn't work. So in this one, they disappeared and they suddenly came back. This one, it's like they kept the bounds the entire time. It was definite the entire time. I don't know. It's a little bit nicer, I think. We've been using the power rule, the general rule for integration. But can you guys help me out? Are there any more rules that maybe we should know? Yeah. What are some ones we haven't seen yet? Yeah, those funny ones, right? Like with the b to the u and all that sort of stuff. Yeah, we haven't done arc trig either. However, there is, and I forgot that I hadn't gotten it yet. I thought I had, but it's not there. There is a nice little table summary in our book, so let's go ahead and check out which ones they added and see if there are any additional ones beyond that. Let's see if I can get in there real quick. Meanwhile, you guys are trying to figure out what those ones are. You're like, something has an ln or a 1 over ln. Here, do you want to watch the Halloween thing while we're waiting? Does anybody see it again? This is intense. Is it for Harry Potter? Fantastical creatures?
I think it's a game. Yeah, it's a game.
Drawing its symbol anywhere?
Yeah, you see how it has a line over its head?
Got it. So I just draw it anywhere?
Yeah.
Ooh.
Now.
Should I pass? We probably shouldn't do this right now. Oh, they do two at once.
Miss D's a wizard.
Well, this is fun. Oh, this just got complicated. Oh my goodness, no way.
Miss D, you know magic.
You're a wizard.
You all gonna be playing it today, aren't you?
Uh-oh.
Woo!
What? Got glasses.
No?
Stop.
It's another one. Hurry up, Miss D.
Stop, it's going in.
Miss D's a
Woo! Alright, we're done. That was fun though. Won't lie. Okay, so have fun with the Google animation today. So
Wait, it's still recording.
So there's evidence of me goofing off in class? No way, we should sue.
And Toronto and Joyce get some fun time.
They do, because they're all going to go to Google and be like, whoa, because they'll actually be on their computer. Gerardo, don't get too distracted. Okay, so, or maybe Joyce. Joyce, don't
She
get too
can't do it on her
distracted.
phone, can she? Or does she watch it?
She watches it on the back computer. Oh my goodness, I should have been doing it right now.
The online book because yes, I haven't actually tried to get the online book. Does it work?
You just have to sign in and then click the e-text. It's a little annoying, but it's not impossible. Where are we at? Chapter 7. Look, guys. Look how far we're coming. And we're done after chapter 10 and a half-ish. Okay. Hold on. We're in section... Ooh! Anti-differentiation by parts. That's new. In Stand and Deliver, it was called Tic-Tac-Toe. Do you remember that one? Tic-Tac-Toe. When Pancho was up there and he was like, I can't do calculus. And he was like, oh, I think somebody has bigger problems than you. Okay, let's see what they have.
What did we do after we watched the movie?
We watched Numbers for a little bit. We watched God's Not Dead. That's right.
Can we watch them deliver or not? No, what's the movie? I didn't get to watch the first part.
Oh, because you're taking AP?
I think.
Oh, stink.
I did this here before.
Yeah, I'm done. I don't know what changes it. Maybe it's when I'm recording. It doesn't like to take pictures. Alright, forget that one. Alright, so now that we've had about 10 times to see it, but none of them good. There we go. Alright, what do they have? There's still a line. How is there still a line? I don't understand.
You have to go to the snippet tool and then... I think you do
But it automatically copies it, doesn't it? I think so. Let me try
You
again.
have to paste it, I think.
Oh, there we go. Oh, you're right. It did automatic. These ones we already know. Pull a constant out. These ones we already know. Sum and difference. The power formula we already know. Ooh, ln, right? That's an important one. There's all the basic trig that we already know. Okay, here's some of the ones you guys were talking about, right? The ones at the bottom for b to v. So we have this one. That's an important one to remember. You should know that one already. This is interesting, but I'm actually not going to have you guys memorize it. We're not making a forever card out of it because there is another way to solve that we're going to see oh so soon called next section. There's a way to actually get this answer, but it's not using anything we've done before. It's integration by parts. Tic-tac-toe. But then there's one other one as well. However, this one as well, I don't think it's super crucial. Because if you notice, guys, what happens to ln of a? Well, hold on. First of all, how do they go from log base a of u du to ln of u over ln of a? Good, change the base formula. And then ln of a, do they have to actually worry about him? It's a constant. So 1 over ln of a comes out. That's why he's the exact same right there, right? Pulling a ghost. But anyway, up here, this is just that, right? So when we learn next section how to do that one, we'll be good to go. However, I don't know why they're not talking about it, and I feel they probably should. What are those inverse trig?
You can't do U sub and you can't do slide integration on crack. You gotta do inverse trig.
basically. We're gonna know it's inverse trig when u sub isn't working, at least not in the traditional sense. Give me one example of an integral that results in the inverse trig.
I got that.
Oh, come on. 1 over.
Something with an x squared on the bottom and just a 2 on
U
top.
squared plus 1.
Because it would be
Yeah, there's a
square
square.
root of 2x.
Not just a 2 though, because that could be u to the negative 2, just power rule. So we have to have a u squared and a number, right?
Yeah, plus.
Ooh, an a. That's interesting. Which inverse trig doesn't have a square root? Tangent. So it's going to be 1 over a times arctan. Remember this guy?
Yeah.
Why 1 over a? Well, remember you can technically factor out the a and then you'll get in that way. I think there's some examples in homework, which is ironic because they couldn't actually state the rules. What would be another one? 1 over square root of a squared minus u squared? Who's this one?
Sine.
Sine, good, because there's no absolute value of u. That's a quick clue. Okay, arc sine is the one who doesn't have a 1 over a in front. I think, does he? I don't think he does. But then we have one more. We also have the arc secant. Why am I not doing arc cotangent or arc cosine? Yeah, same but with a negative. Sure. So we have the integral of 1 over absolute value of u times the square root of u squared minus a squared du. That's going to be 1 over a arc secant of u over a plus c. So there are those inverse trig integrals. Maybe they'll come up at some point. You guys know this book is a little funny, but otherwise most of those were okay on. The last ones get funny, but remember, just save these for me until next section and come back. I'd rather you see why it is what it is. But here's that little 1 over ln of a times a to b.
Wait, let's see. So it's arc cosine. It's now the negative instead of arc sine, or is it?
Yeah. So it would be arc sine. Put a negative in there, and it's going to be arc cosine instead. Does that make sense?
I just thought it was secant.
And if I throw a negative, just for sake of clarity, arc cotangent, and throw a negative in, maybe 1 over a. I might have said it wrong. Plus c. Woo! So what if I was to? Ooh. Wait a minute, this doesn't necessarily go with inverse trig. What would you guys do?
A lot of 4.
A lot of 4.
Try to factor the bottom.
Oops. Lost my page. We should automatically next to the others. I just lost my directions, didn't I?
So you, what's your difference?
There it is. Huh. Okay. What's a different example? Okay, pull out a 4.
5. No, right.
That's super long.
And then we have to use the bottom.
Yeah, we could do u sub to the bottom. If we did do u sub to the bottom, we would get u is equal to x squared plus 2x plus 5, which means du is equal to 2x plus 2 dx.
We can pull out a 2.
That's good.
And then we can, and then we do x plus 1.
Okay, so we're going to go for it. So dx is equal to,
Du over 2 times x plus 1.
is that good?
And then equals 2 on the outside.
You can pull the 2 out too.
And then you get 1 over u.
Yeah.
So the ln of u.
So we get 2 ln of absolute value of u, and u was x squared plus 2x plus 5. Plus c.
What we're doing value. Oh, no, we're not. Never mind.
No, we're good. I was just seeing if you could integrate.
Just do that.
That was interesting, right? It looked like it was going to be a lot harder, and then it wasn't that bad. So is it going to stay that easy? Still a little tricky. Let's try this one.
Ooh, this this one has to be.
Ooh, why? What do you see right away?
There's no X on the top.
There's no X on the top, so I can't even think about U sub with the entire denominator, because what I just saw was you had to, okay, the constant might be a little bit off, right? It was a little bit off, but at the same time, at least I had an X and I had a constant. And even, to be honest, even if there was no constant, I could have made one if I needed to. Struggle on this one, I got, it has to be arbitrary. If I have a denominator, I have someone squared, and the U sub is just not going to match up. So, which arbitrary formula seemed to include a non-square root?
Tangent.
Exactly.
And then it's U squared and then plus U prime times U prime. Yeah.
But who's being squared?
X squared.
That doesn't belong. Like, I could make this a U squared, right? I can make this an A squared, but he doesn't belong. So the 2x, somehow I have to make him a part of the U squared. Well, how do I make him a part of the U squared? I have to make him a U squared, and the only way to make him a U squared is to make him a perfect square. And the only way to make him a perfect square is to complete a square. I know what you're saying.
So then,
Can I put a 1? Does that work? Because then, just looking ahead as to what we're trying to do, that would go ahead and get us x plus 1 quantity squared plus, if I add 1 here, I need to subtract 1 to offset, right? And I end up with 4.
So then our U is x plus 1 and our A is 2.
And our d is no big deal because it's just dx, right? And then our a is equal to 2. So we can go ahead and say, sweet, we have 1 over u squared plus a squared du, which means we can go straight to 1 over a arctan of u over a. And so 1 over a is 1 over 2 arctan of x plus 1 over 2. And then we got it. Technically, we could have done this without, which would have been really messy, without using the A idea. I personally like the A idea better. If we had done this without the A idea, we would have gone ahead and kept basically all of this all the way up to here. I know you guys always memorize everything, so we're totally fine, right? But just in case. How else could we have gone to make it match up with the u squared plus 1 of the original tangent? We could have gone ahead and pulled out a 4. So we would have had a 1/4 x plus 1 quantity squared plus 1. Then we could have said that this is the entire thing of, instead of 1/4 x plus 1 squared, we could have said, hey, that could be 1/2 x plus 1 squared. Then my u could have been, yes, I apologize, u is equal to 1/2 x plus 1. Du would have been 1/2 dx. Dx would have been 2 du. Then this 1/4 would have come out. We would have had the integral of 1 over u squared plus 1 times 2 du. The 2 would have joined the 1/4 on the outside, which would have been 1/2 arctangent. These two ways to write it. Of u, and who was u?
X plus 1.
Exactly. 1/2 x plus 1. And isn't that the exact same thing as x plus 1 over 2? Right? I like memorizing the 1 over a, arctan of u over a. Plus c, but it's up to you guys. You do not need to be forced into a box by me. Okay. How about this one? Oh, he's easy. No, he's not. Why not? Maybe. Integration on crack. Hey, that's a thing. Gerardo, you're like, what? Let's go ahead and just, guys. What would you think of doing? Everyone probably. What would
U
you?
is 2x minus 1.
Yeah. No big deal. Until you come here and you're like, stink, right? Question, who's not going to cancel out when I plug in for dx?
Then we have to solve for
Exactly. So you come back over here and say, but wait a minute, can't I get x in terms of u, which might seem a little roundabout, and it's not always helpful. And as we saw on the page before, straight out u sub without thinking of other ideas is not always straight out helpful either. So then as we come in to plug in, we can say, okay, fine. X can become u plus 1 all over 2. 2x minus 1 to the 7th is just u to the 7th. And then dx becomes du over 2. You guys see the 1/4 that's coming out? How on earth am I supposed to integrate u plus 1 times u to the 7th du? How did that help anybody?
now we can go u to the 8th plus u to the 7th.
I can undo this multiplication a lot easier than I could have undone this. Who wants to raise 2x minus 1 to the 7th? Not me, not you. But this little distribution is no big deal. U to the 8th plus, and we could do Pascal's triangle. And fun as it is, it's not very practical on an AP exam. But we can do that distribution real fast, and we can say, oh, sweet, that's going to end up being 1/9, u to the 9th, right?
Plus 1.
Put the 1/4 out here, that's a 9, in case it's
1/8
in. Plus 1/8, u to the 8th, plus c. And then, now, what would the AP guys do at this
They
point?
would multiply it by 1 over, no, u over,
They get these in terms of 70 seconds. Nope. They would get common denominators. There we go. So we end up with 1/4
times 8 over 2 u to the 9 plus 9 over 2 to 8. And you have 8 u to the 9 plus 9 u to the 8, and then you pull out a u to the 8.
and they pull out a
1 over 72.
and a 4 times 72 would be 288. Does that look right? And then you would have an 8u plus a 9, because the u is now gone, right? That's totally something they would do. And then they would say, hey, who's you? Or maybe they would have done that earlier, but now it's easier to plug in. And you would have your 2x minus 1 to the 8 times 8 times 2x minus 1 plus 9. Be like the proper, you might put a bracket there instead. Then they would have gone ahead, oh my goodness, and distributed, and they would have gotten 16x minus 8 plus 9. Then they would have gotten 16x plus 1, right? So that was exciting, huh? Not impossible, but once again, we had to kind of think outside the box and officially, Gerardo, this step of having a U and going and solving for X and plugging in is what we call integration on crack, because you don't usually think about it. It's just kind of crazy. It's out there. Math is better than drugs. Okay, so what's this whole slide talking about? Quick heads up, remember the AP guys can trick you or do something funny where somehow some function has even symmetry, which means f of negative x is equal to positive f of positive x, I should say. Odd function, remember f of negative x is the opposite of the original. If a function is odd and you have symmetric bounds, negative a to a, the integral is always going to be 0. If the function is even and you have symmetric bounds, then it's always going to be double, just going half the direction. I think we might have seen this in one problem so far this year with the AP guys. I don't remember why. I think in the old book there was like a homework problem that needed this, so I decided just to quickly remind you of it. But it doesn't really fit perfectly in any place, but that's okay. Quick reminder. And with that, cool kids, boop, we're done. How many of you guys need to write down the homework in your spiral? You already have it written down? did you? Okay, hold on. As you guys are doing this, I thought of another good example type. I'm trying to see if I can remember it though. What if I was to give you, can we do one last example? Just because, to be realistic, to have you guys get out your homework to work on it for 3 minutes is probably not very helpful. Sorry, please do that. You good?
I'm good, yeah.
Okay. What if I was to give you the following? Something happened. Well, it's not like the other one, right? It's gonna be super fun. What would you guys say we should do?
And you won.
Not thinking arc trig yet because there's an X on top, right? Who's du?
Oh, struggle. And the dx.
So then dx is equal to?
Oh, spaghetti.
How do we deal with that, guys? Can I do that? Or how does that help? What am I doing?
Put in another thing on that side. Oh no. 7. Wow.
Well, he's my U, right? Uh-oh. Oh, wait. Hold on. I'm going to keep them like this for just a second. And now we have our Steve, that's only good with what part? No way. What am I doing?
Put it in there.
7/2 stands to be his own little dude. How come? Because I don't want him. But what am I going to do with him?
No,
I'm going to say, you know what? I want you to be your own little dude. I don't want you in U's yet. I need you to be complete and square, and I need you to be arc trig. Then on this one, I can go ahead and just make him a 1 over U, and then those can reduce, and then I have ln of U over here. And that was good for that piece, but what am I going to have over there? Arc. Very cool, kids. Get out of here. We'll talk more about it tomorrow. Sound good? We'll finish that nice, fun one. You're welcome.
thank you for not making it a 3-hour score.
Oh, I'm saying. Because that would have made it even. If you want to trick or treat on the way out.
There's you.
You're welcome. It would have been nasty otherwise.
Oh,
No, you don't want that?
Sure.
Poor Georgie, I forgot to say one. Wait a minute, good try.
Bring the water bottle on.
Thank you.
No, you're good.
We have a lunch meeting, right?
Yeah, I think I saw that. Thank you, Sam.
What's the, like, I wouldn't say the easiest class you teach, but like, what's what's like
The lowest,
Yeah.
like the earliest,
Yeah.
pre-calc. I used to teach algebra 180 back in the day, but there are too many higher classes, so I don't have room in my schedule.
I'm never